All right, G. So, chapter which we are going to begin and is under discussion is basically work, power, and energy. And we will be discussing the syllabus, and focus will be we will be discussing the term which is first of all called as K. We will be what is a work. Then we will discuss its formula. That work is found from force into displacement in the direction of force. Then we'll be discussing about the energy, and in energy there is a law, that is law of conservation of energy, or a principle of conservation of energy. We will be studying about the term called as efficiency, as a ratio of useful energy to the total input energy. Plus, we will be studying about and we will use that efficiency to solve certain questions and problems. Then we will be discussing about the term power using the property of work, or a definition of work, that work done per unit time. And using this formula, we'll be deriving another formula for power, which is P is equals to force into velocity. Moving onwards, we'll be discussing two more types of energies in it, the formulas for them. And one of the formula is for the gravitational potential energy, that in a uniform gravitational field, what it is actually, and its formula is mgh. And likewise, we will be using this formula in certain calculations. And last but not the least, we will derive. So you can see these two very important words in three specific case. One is you should be knowing the derivation of power formula, P is equals to FV. You should be knowing the derivation for work formula, sorry, gravitational potential energy formula, MGH, and you should be knowing about the derivation of the formula kinetic energy is equals to half mv square. So this kinetic energy formula, half mv square, appeared in 2025 May-June paper. So in a May-June paper, this the derivation of this equation came into your examination. And last but not the least, we'll be discussing how to use and where to use the kinetic energy formula as half mv square. So this is the total syllabus of the chapter work, power, energy, and you can witness that majority of the things you would have been seen in your previous years as well. So let's move on with our very first term, which is called as work done. So मैं request करूंगा आप सबसे कि please you must be taking the notes thoroughly. I'll be adding on few more terms, few more things into the lesson apart from the things which will be displayed as of this PowerPoint slide and on. Everyone is with me?
Yes, yes, sir.
Okay.
Yeah.
Okay, Ji. So let's move on. Next term is Our next term is known as work done. So I do believe that you people are able to see the screen, and we will be just discussing what it actually is. So work done, it is pretty very important to understand the term work done, that what it is. So for instance, if I am having one of the block, right? Let's say this is a block which is having some mass m, and if some force is exerted on this block, and when force is being exerted and this block or the object begins to cover some distance, what it begins to cover, it covers the distance, and this distance is being covered in the same direction as the force, यानी कि जिस डायरेक्शन में फोर्स exert हो रही है उसी डायरेक्शन में अगर डिस्टेंस कवर होगा, तो we are going to say that work is done. We are going to say that work is done. So what's a prime and basic definition of the work done? Work done is defined as the product, ये आपके पास definition लिखी हुई है. Work done is defined as the product of force and displacement in the direction of the force. What it means to here, it is using the word of displacement. Like when the distance is being covered in some specific direction, it becomes displacement. And what direction is in focus? It is the direction of force. So, for instance, if any body is experiencing a force, and if it covers a distance in the direction of force, then work will be done. So, in a simpler way, I can say, and you must add on this point with you, that if a force is exerted on an object and it covers a distance in direction of force, in the direction of force, then what we are going to call, we can say work is done. And as per this statement, we can say that work is what? Work is equals to force multiplied by distance in the direction of force. So this is the pretty basic formula for work done. Work done is equals to force into distance. But now the question comes, will there be no work done if the force is not aligned with the distance traveled, or if force is not same as the distance is being, if the direction of force is not same as the direction of the distance covered? So question is, yes, still a work is going to be done to some extent, but the maximum work is only done when force and displacement are in same direction. So let's say there is one force which is in this direction and distance is also covered in this direction. Only then the maximum work will be done. But for instance, if there is a case where force is exerted like this way on the block, this is a block being shown at an angle of theta, at an angle of theta with the horizontal. And for instance, it covers a distance s. It covers a distance s. It is having one displacement s horizontally. Now, what we are going to do? We will find the component of the force which is in the direction of displacement. तो ये पॉइंट अपने पास लिखें. If force is not in same direction as distance covered, so a component of force will be found which helps in work done. ठीक है? So can anyone tell me on a mic what is the component of force going to be there in finding out the work done? अगर मेरे पास एक फोर्स F लग रही है जो कि एंगल थीटा के ऊपर है, तो इसका कौन सा ऐसा कंपोनेंट होगा जो डिस्टेंस की डायरेक्शन में जाएगा? Yes, can anyone tell me?
Sir, the x component.
It is going to be the x component, it is going to be the horizontal component, and what this horizontal component is going to be known as, this is going to be called as F cos of theta. Recall the resolution of vectors. तो जब भी एक फोर्स एक्ट कर रही है at an angle theta, so this horizontal force F cos of theta will now be a force which is same as in the direction of the distance. तो इस केस को देखते हुए हमारे पास वर्क का फॉर्मूला क्या बन जाएगा? वर्क डन, work done is equals to F cos of theta multiply by distance. So let's say here the distance is represented as S. So work done will be shown as what? Fs cos of theta. तो ये basic formula है for finding out the work done. ये basic formula है to find out the work done. So work done will be equals to what? Fs cos of theta. Work done will be equals to Fs cos of theta. और यहीं से हम ये फॉर्मूला बना सकते हैं कि when theta will be equals to 0 डिग्री, यानी कि थीटा जीरो होने का मतलब क्या है? फोर्स और डिस्प्लेसमेंट एक ही डायरेक्शन में है. तो कॉज ऑफ जीरो हमारे पास क्या होता है? इट विल बिकम एफ एस कॉज ऑफ जीरो which is equals to F into S. The people, are you understanding the concept of work? What is work done means in terms of physics? Please acknowledge. Everyone is with me. What does the term work done means
Yes,
when
sir.
we are stating कि जब भी किसी बॉडी के ऊपर फोर्स लग रही है और वर्क हो रहा है तो इसका मतलब एक्चुअली है क्या? सो इट मींस व्हेन अ फोर्स इज अप्लाइड ऑन एन ऑब्जेक्ट और उस फोर्स की वजह से बॉडी उसी फोर्स की डायरेक्शन में मूव करे, तो देन वी आर गोइंग टू कॉल कि वर्क इज गोइंग टू बी डन। और आपने हमेशा कौन सी फोर्स जो है वो यूज करनी है वर्क डन को फाइंड आउट करने के लिए? You will be using a force, that component of a force which is in the direction of the distance. So that can be, again, that component of force can be found using the resolution of vectors. So we know the horizontal component in this specific case is F cos of theta, and vertical component is represented as F sine of theta. Shall I move on? So here you can see what subscript means. W means W work done, F means constant force, S means displacement, and angle theta is between the force and the displacement. Please do tell me if it's done, so shall I move onwards?
Yes, sir.
चलूं आगे?
Yes,
जी
sir.
सर।
Yes, sir.
So unit of work. The SI unit of work is called as joules. What is the SI unit of work? The SI unit of work is called as joules. And if in exam or if it is being asked to define 1 joule of work, so how are we going to define 1 joule of work? The 1 joule of work can be defined as if a constant force of 1 Newton is applied on an object moves a distance of 1 meter in the direction of force, then the work done will be 1 joule. तो आप इसके फॉर्मूला से भी देख सकते हैं वर्क डन हमारे पास क्या होता है, फोर्स इंटू डिस्टेंस होता है। फोर्स भी 1 न्यूटन की लग जाए और डिस्टेंस भी 1 मीटर का कवर हो इन द डायरेक्शन ऑफ फोर्स, देन आवर वर्क डन विल बी इक्वल्स टू 1 joule. Is this fine? G Hafsa, your question is, sir, in every case we have to take the force parallel to the displacement. Yes, जब भी हमने work done find करना है, we are always going to take that force which is parallel to the displacement. So if displacement is horizontal, your force applied will also be in the or is to be taken in the horizontal direction. Shall I move on? Hurry up, people, please speak up.
Just a minute, sir. 1 minute.
Okay, next term. So at times you can say there are certain scenarios in which you can say that work, like even if a force is being applied, लेकिन work जो है वो zero हुआ, और कब work हम ये कहेंगे कि work done is positive और कब हम ये कहेंगे that work done is negative. तो उसके कुछ scenarios हैं. Let's say सबसे पहला scenario देखते हैं. For example, when force is applied लेकिन object move ही ना करे, ठीक है? When force does not move the object, किसी भी body के ऊपर force लग रही है but that object is not moving, in that scenario our work done will be zero. Why our work done will be zero? For example, work done is given by a formula W is equals to F into D. Force तो लग रही है but no distance is being covered, so anything multiplied by zero is getting as 0 joules. So our work done in this specific case will be zero. और इसकी example क्या है? Let's say a man is pushing a wall. So when you push a wall, when any man is pushing a wall or any person is pushing a wall, in that specific case, you can witness that force is applicable, but no distance or displacement has been covered. So we can say work done in this case will be 0 joules. Second thing, let's say on one of the body, force is perpendicular to the object's movement. For example, इसकी छोटी सी डायग्राम मैं यहाँ बनाता हूँ ब्लॉक के केस में. For instance, that object is moving or covering a distance d, and there is force. Let's say that force is acting upward. So what is going to be the angle between them? Let's say 90 degree. So the force is upward, distance forward. So we can say both force and distance are perpendicular to one another. In this also specific case, the work done will be zero. And we can prove this mathematically as well. How? We know W is equals to F S cos of theta. And from this, we can also state that W is equals to Fs perpendicular का मतलब है कि cos of 90 डिग्री. तो cos of 90 हमेशा किसके इक्वल हो जाता है? It will be equals to 0. So this mathematically it also reveals कि जब भी आपके पास force और distance perpendicular होंगे, work done on the object will be 0. Is this understandable?
Yes, sir.
And when we are going to call that the work done is positive, work done will be positive, work done will be positive कि अगर force की direction और distance की direction एक है. So let's say there is a man which is pushing a trolley. So if there is a man which is pushing a trolley moving onwards, so you can say that force and distance are in same direction. So the work done is going to be positive. And when is the work done going to be negative? Let's say an object is moving forward and there is one frictional force acting on the object. So we can see when force and distance are in opposite direction to one another, we will call the work done as negative. Why the work done will be negative? Because अब इनके दरमियान angle कितना बन जाएगा? 180 degree. And if we just see the formula of work done, W is equals to F into S cos of 180 degree. The cos of 180 is equals to, if you just type it on the calculator, it will be equals to negative times of Fs. So friction always opposes the trolley's motion is an example where work done is said to be negative. तो कोई भी जो रेजिस्टिव फोर्स होती है जब भी कोई ऑब्जेक्ट मूव कर रहा है और कोई भी रेजिस्टिव फोर्स उसके ऊपर लगा रही है या लग रही है या एक्ट कर रही है, that resistive force will always cause a negative work done, and negative work done always slows down the object. It always decreases its kinetic energy. So positive work done increases the kinetic energy. Positive work done increases the kinetic energy, and negative work done decreases the kinetic energy. Is this understandable?
Yes, sir.
राइट. तो ये लास्ट में बॉटम पार्ट में ये एक पॉइंट भी कुछ लिखे हुए हैं, यू कैन जस्ट keep it in your mind as well कि positive work done always increases the kinetic energy of the trolley while negative work done decreases the kinetic energy of the trolley, and zero work done means कि हमेशा kinetic energy क्या रहेगी? It will always remain constant if any object is moving. तो अगर कोई भी ऑब्जेक्ट मूव हो रहा है और वैसे मूव हो रहा है कि उसकी काइनेटिक एनर्जी कांस्टेंट है, इसका मतलब कि इस केस में आपके पास वर्क डन जो हो रहा है दैट इज इक्वल्स टू जीरो. वर्क डन विल बी इक्वल्स टू जीरो. जी गाइस, इज दिस अंडरस्टैंडेबल? शैल आई मूव ऑन?
सर एक सेकेंड.
ओके.
सर आप ये एक्सप्लेन कर देंगे कि वर्क डन पॉजिटिव नेगेटिव और जीरो होने से काइनेटिक एनर्जी कैसे चेंज हो रही है?
अच्छा देखो, हम आगे चल के भी ये टर्म पढ़ेंगे भी कि फॉर एग्जांपल जब भी किसी बॉडी के ऊपर वर्क डन हो रहा होता है, if any force is doing work on any object, work done always is stored in the form of energy in an object, right? So if I say that there is any object, like there is any block, जो पहले शायद मूव नहीं कर रहा था, and now I am going to apply a force, और उस वो एक डिस्टेंस कवर करना शुरू हुआ, यानी कि वो मूव करना शुरू हुआ. It means any object which will begin to move, it will be having some speed, it will be having some motion, तो जितनी ज्यादा फोर्स लगती जाएगी उसकी मोशन क्या होती जाएगी, बढ़ती जाएगी. इट मीन्स कि जब भी पॉजिटिव वर्क डन हो रहा है तो बॉडी की काइनेटिक एनर्जी बढ़ेगी. एंड व्हाट इज काइनेटिक एनर्जी? काइनेटिक एनर्जी इज द एनर्जी ऑफ अ बॉडी possessed due to its motion. So as the speed increases or if any object moves from rest to a motion, so its kinetic energy increases. Likewise, अगर कोई let's say गाड़ी है और गाड़ी जो car is moving onwards, right? Car is moving onward and there is one friction which is being exerted by the tire. The friction is in the opposite direction, distance covered is forward, right? So continuously this friction is dragging the object in the backward direction and it tries to cover a distance in the forward direction. तो अगर एक्स्ट्रा फोर्स इंजन ना लगाए तो स्लोली क्या होना शुरू हो जाएगा, इस फ्रिक्शन की वजह से गाड़ी बिगन्स टू स्लो डाउन और स्लो होते होते इट विल कम टू रेस्ट. तो जब किसी बॉडी की स्पीड कम होना शुरू हो जाएगी उसकी काइनेटिक एनर्जी डिक्रीज कर जाएगी. Is this
Okay, sir.
understandable?
Thank you.
Okay. Shall I move on?
Yes, sir.
Okay, these are few examples, so let's see them quickly. So question says the following are examples of work done by a constant force. Work done by the man on the box is being shown, right? So this is a person which is applying a force of 10 Newton and it is covering a distance of 30 degree. Sorry, it is at an angle of 30 degree and is covering a distance of 10 meter. So question says what is the work done by the man on the box? तो हम कैसे find out करेंगे इस case में work done? Work done will be equals to F into S cos of theta. So we know what will be the force. The force applied is 10. What is the distance covered? It is 10. And we are going to see the angle. And this angle will be cos of 30 degree. So 10 into 10 will be equals to how much? 10 into 10 will be equals to 100 cos of 30 degree. It will be giving us an answer nearly 87 joules. So work done will be equals to 87 joules. Is this fine? So you have to memorize this formula for work done. Work done किसी भी एंगल के लिए कि कोई भी एंगल हो 360 डिग्री में से. The basic formula for the work done is Fs cos of theta. So let's see another basic example on the right hand side, part B. Work done by the man in opposing the sliding box is what? W is equals to Fs cos of theta. So let's say there is a person which is applying a force in this direction and the block was somehow sliding to the right, and during sliding it covered a distance of how much? It covered a distance of 10 meters, right? So we can witness that the angle between the force and the distance is 120 degree. So what it will be, it will become that W is equals to Fs cos of theta and force applied is 10 and let's say distance covered is 10 and cos of angle between both. What is the angle between both? 120 degree. So resolving this whole will give us what value? Minus of 50 joules. So we can say this is when the force is in the opposite to the moving object, it slows down, and the force is in the same direction in which the distance is being covered. The it speeds up or its kinetic energy increases. Is this fine? Yes, people
Yes, sir.
speak up. Are you people getting it? Whatever we are discussing?
Yes, sir.
Yes, sir.
Shall I move onwards?
Yes, sir.
Right? You must be noting down these examples in your notes as well. मैं आपको साथ साथ ये शेयर भी कर दूंगा. After the class, I'll be sharing the document with you as well. Okay, Ramzara, sir, can you explain why it's negative? Yes, beta, अगर आप cos 120 type in करें on your calculator, so cos 120 will be giving you a negative answer, right? So cos 120 negative आएगा, so the work done will be in negative. All right, so there is a minute एंड जिसमें ये हमारा सेशन ख़त्म हो जाएगा, तो मैं आप सबसे रिक्वेस्ट करूँ प्लीज़ दोबारा री लॉग इन कर लें।